All right, next up we have Julia, who's going to be talking about some interesting research. Julia's talking. She's going to be presenting some content from the developer side of defense. Right? We've got a lot of talks, security researchers, hackers. She's going to talk about working for a company and why to report it and how they fix. So let's give a round of applause for Julia. Feel free to take your whole 25 minutes.
Well, hello. My name is Julia Vashchenko. I come from Kyiv, Ukraine. First of all, thank you for having me. It's really an honor to speak at such a prominent conference. I work for MacPaw. You might have heard of our products. Statistics say that every fifth Mac on the planet has one of our products installed. I work as a software engineer at CleanMyMac on anti-malware functionality. Also, I'm a member of the triage team. And okay, so simply put, I'm the person who writes the code for anti-malware. Also, I deal with the bugs that are reported to us via HackerOne. I work on technical decisions, and often I'm the one who implements the technical decisions. So, I've been with the company for around a year, but my story for today is a bit longer, about 1.5 years. Also, oh wow, what's going on? What is going on? Okay. Okay, also I'm a macOS chapter lead of Women Who Code Kyiv. Yeah. So, side note, I don't know, but probably it is the first time on Objective by DC conference that you're gonna have a talk on pretty same subject twice. Yesterday, Wojciech Hrygula was talking about abusing and securing XPC on macOS apps, and I will elaborate on that topic. So please bear with me. The next 25 minutes, I'll try to bring another perspective on this. I'm going to talk about and CleanMyMac. They are already fixed and deployed, but I believe that the root cause is still there, so we'll come to that at the end of the talk. Also, I want to mention one thing that made this talk possible. It is our take of security at the company. We do really care about our users, and this is actually what made this story and this talk possible. So we're going to start with a short intro to privileged operations on macOS, just to make sure that we are on the same page about this. Then I'm going to talk about several issues that were reported to us by different researchers. Also, besides CleanMyMac, we have another big product, which is called SwiftAveiro. And I have a unique opportunity to compare the implementation of privileged operations on CleanMyMac and SwiftAveiro and the amount of bugs that were reported to us. There is one more thing that I want to mention. I want to say that I appreciate the great, tremendous work that Apple engineers do, providing us with great platforms that I personally love using and working at. But sometimes it looks like tough love, especially at the end of the talk you'll see. I hope you like it. So, our short intro. If you want to do some privileged operations on macOS, you have basically two high-level APIs to choose from: SM jobless and authorization execute with privileges. SM stands for Servers Management, is the name of the framework. It is actually a pretty easy choice because authorization execute with privileges has been deprecated since macOS Lion. And also the documentation tells us that it poses a security concern, not something we want to do. The problem is in the flow. Basically, you can run anything using authorization execute with privileges. A signed binary, unsigned binary, a script, it could be as easily tampered with and it could be easily replaced. So you basically don't know what you're running when you're running it. Also, the documentation tells us that we need to use the service management framework, which is SM-jobless. Okay, but even at the start, a developer can see that something is not ideal. For example, there is no mirroring API. There is nothing we can unbless after we blessed it. Everything is deprecated. Also, remember yesterday Scott Knight's amazing talk on endpoint security? He mentioned on one slide that the flow of registering a system extension involves some privileged operations, and they are registered with SM job submit, which you can see is long deprecated. So even Apple engineers, when writing a brand new shiny framework, they have to use deprecated APIs. This is what's happening right now. The main difference between SM-jobless and authorization execute with privileges is requirements to sign in. The client application has some sign-in requirements to the privileged helper, and the privileged helper has sign-in requirements for the client. But the operation validates these requirements only on installation and subsequent updates. No validation is performed on establishing the connection to the privileged helper. Let's see how the flow goes. Some prerequisites. The client is a bundle and it has to have the executable embedded, the executable of the privileged helper. All the sign-in requirements should be met. Both the client and the privileged helper have to be signed. Also, the privileged helper has a plist and a LangD files, both embedded into this executable. The plist contains those sign-in requirements, and the client has the sign-in requirements in its plist. So, they depend on each other in this matter. In order to make this work, we need to obtain an authorization object, so we call authorization create. At this point, user sees the alert, which prompts the administrative password. If everything goes smoothly, we obtain this authorization object and we feed it to the SM-jobless function. Then, operating system validates those sign-in requirements and copies the executable from our bundle into /library/privileged helper tools. And it does one more thing. It registers this privileged helper as an XPC service, so anyone on the system can talk to it via XPC. And when we try to talk to it, a method listener should accept new connection is called on the privileged helper. So far so good. Okay, we want to implement it. What do we do? We go to Apple sample code, and after some digging, we realize that there are two samples for that, a better one and an even better one. Unfortunately, there is no good one, as you can see, and I'm going to show you this a little bit later. Let's see the even better one. It must be like super best, right? Okay, this is the implementation that we are supposed to do. Basically, it says, anyone wants to talk to you, configure the connection and return yes. Don't care who wants to talk to us. And this is what we did on CleanMyMac. And this was our first issue. It leads us to the point when we were reported this issue by Cisco Thales Intelligence Group. On November 2018, our security engineer, who is actually there, Artyom, thank you, he just stumbled upon some zero-day reports on CleanMyMac, a bunch of them actually. Here you can see our whole interface of the privileged helper and a CVE for each method that we provide. Thales tried to contact us, but the letter got lost, so we didn't fit in the timeline, and they published. We contacted them, they provided the details, all we needed the same day. Then we released a patched update. After some time, they reported an insufficient fix. The problem was in the update mechanism. So everything was correct. It wasn't just updating correctly on the end-user machines. And at the beginning of 2019, Tyler Bohan from Talos, the guy who actually reported all those CVEs, delivers a talk in Berlin at Vashchenko 19 about this funny situation. And after that, we released the patch with the correct update. Tyler was talking about a bunch of applications, again, our interface. And we appear to be in good company, I'd say, with Microsoft, Pixar, Wacom, Spark Labs. Funny, right? Like, developers from Microsoft do the same stupid mistake. How does that happen? Okay, and Tyler suggested, during this talk, Tyler suggested a fix that we had already implemented by then. The fix was in this function. In this method, we are going to see this quite several times. We check that whoever wants to talk to us is signed by our company and its signature is intact. Okay, looks good, right? Do you remember Scott Knights yesterday had a very similar code sample when he showed Apple engineers fix on his report? It looked pretty much the same. They did the same mistake. They forgot to check for the entitlements, and this was our fix. But it appeared to be just the first fix. We decided that we do really need good engineers to look closer to what we do and is it secure and how things are going on. So we decided to add CleanMyMac to HackerOne. We added it as to the scope on May 2019. By the time we had already having a HackerOne private program running for almost a year for setup. At that time, what did we have? The client's requirement for the privileged helper was to check for the bundle identifier and the sign-in identity, the team ID. For that, we received the bug that actually the privileged helper executable can be replaced in our bundle with an older version. You can see that it was reported to us by Vladimir, who actually delivered a talk yesterday on quarantine. There is a funny thing, because we went to HackerOne because we wanted that researchers from all over the world to report us bugs, but all the bugs on privileged operations were reported by Vladimir, who actually works a few blocks away from us. What's the problem with the old versions? Okay, it can be replaced with an old version. There is a problem because hardened runtime was introduced only in Mojave. Before that, dynamic library injections were easy to make and hard to detect. So also, Xcode, for some reason, I don't know, added the get task allow entitlement into the release builds by default. I don't know why would they do that, but they did. So you can attach to the process with a debugger, right? You need this in the release build, right? Yeah. So it is quite typical for a macOS application to have a low deployment target. We have deployment target of Yosemite, which didn't fit in this slide. We support all these versions with one binary. And yes, if you find an old version, it is very, very likely that the application that was written for Sierra doesn't have any protection against dynamic library injection, and you can use this part to replace and then make this injection, and you're good. So, the steps. Two preconditions. The privileged helper isn't authorized yet, it lives in the bundle, and there is a malicious executable on the user's computer. First, the malicious executable downloads an old version that is vulnerable to dilib injection. It replaces the privileged helper executable in the installed app with the vulnerable one. Users authorizes the helper, so the system copies it to the /library/privileged helper tools, and you perform a dynamic library injection into the helper. So, doesn't it break the code signature of the bundle? No, it doesn't. So yes, it does, but it doesn't matter because operating system validates the signature only if the bundle is quarantined. So after the first launch, everything is great. It is on Mojave, and earlier we are promised that time-to-time checks will be time-to-time signature checks will be performed by the operating systems on Catalina, but it is just the latest OS, and they say they do it like from time to time. The fix was to add a version check. Basically, it is something similar that you said was implemented in Lulu yesterday. Next one. In privileged helpers requirements, we had only requirement for the sign-in identity. So the client has to be signed by our company. For that, we received a bug that old buggy client versions can connect. It is pretty much the same as with replacement the privileged helper. Here we replace the client. So the preconditions privileged helper is authorized and a malicious executable is present on the user's computer. It downloads an old app version. In the first issue, it replaced the privileged helper, but now it just launches the old client, makes a dilip injection, and it calls the privileged helper, and the code is executed with root privileges. In our case, due to our interfaces, it leads to LP to root. So the fix was to check for the bundle the version of the client. So old client can't connect to us. And we received another bug for the same stuff. With these requirements, other apps of the same vendor can connect. And this can be a problem because not all the apps are maintained in the same way. There are apps that are just on support and there is no time or to think about their security. They are not the priority and then can be used against us. So we added a check for a bundle identifier. Also, in the privileged helpers code, before performing all the checks, we need to obtain the code object, and we use the process identifier for that. And actually, anyone could impersonate the client due to racy nature of the process identifier checks that are performed by the operating system. This is the exploit short version that we got. We are gonna, I think we have a little bit of time to go through. It is, we start with a serialized selector, remove item with path, remove item at path. It is a method from the interface of our privileged helper. Then we fork a process, 100 processes here, but actually like 10 is enough. We establish a connection to the privileged helper, send the message to remove some file, and then we POSIX-spawn the same helper binary because it is signed correctly and it is small. And by the time the check is performed by the helper, the process has already spawned and all the entitlements are correct. So it's like it takes approximately 10 times to get through and to get this file removed pretty quickly. So the fix was not to use the process identifier, but to use the audit token. There is a catch though. It worked. It works perfectly, but there is a problem. The audit token API is private, and a good developer doesn't want to use private API because we want to have stable code base. We don't want any surprises. And when we are working with private APIs, the behavior can change on patch versions on the macOS, and no one's gonna tell us about that. We're gonna have bugs. So we use private APIs only in situations when we can't do without them. But unfortunately, this one looks like the case. So we use it. Next one. This is probably my favorite one. Comparing the privileged operations implementation. When we got the bugs, the first bugs, I went to setup and I told them, hey guys, do you want to look closer to your implementation of privileged operations? Because we are receiving some interesting bugs. Maybe we can fix them in CleanMyMac and in setup if you have some. And I figured that they actually use this dangerous deprecated API that I mentioned at the beginning, which poses a security concern as by Apple. So the question is how many bugs they were reported? This many bugs. Because they use this interface just to call the system binary RM, and you cannot replace it or forge it without having root privileges. So it doesn't make any sense when you use this API correctly. It actually is secure. And for now, it is like this. We have 5 major bugs, and setup has none. Okay, but CleanMyMac did the right thing. We did what Apple told us. We didn't use deprecated APIs. We used the simple code they gave us. Okay, this is how it worked for us. Some short takeaways. First, takeaways for developers. Think about security a little bit. A good start is having a security handle email, so if people find something, they can actually contact you. It's a good start. And have one source of truth for client sign-in requirements and for the privileged helper sign-in requirements. For example, you could put them into the preprocessor macros. I'm going to show you this. These requirements basically describe who you believe, who you trust. Use them in the info.plist file. They will be evaluated on the installation and on the updates of your privileged helper, and use the same requirements in the listener should accept new connection. So you'd be sure that the client which is connecting to you is someone you trust. Check at least for sign-in identity, bundle ID, and minimum version. Probably also check for the flags that were mentioned yesterday, hardened runtime, all this stuff, but if you have low deployment target, probably there was no hardened runtime on Yosemite. When you copy the code object, use audit token, and do not use the process identifier because it breaks easily. And in order to be a good citizen, unregister your privileged helper via launch control or SMJob remove API, deprecated. And remove the executable from /library/privileged helper tools. Also remember to remove the auto-generated list from /library/launch daemons. About the macro definitions. For example, you can add them to your build settings, the client identifier, minimum version, and sign-in identity. Then create the macro definition with them. Remember the escapes. I made this screenshot on purpose because it took some time to figure out the escapes. Then use this macro definition both in your info.plist file and in your code. That's it. If you have an XC config file, you'll probably want to put it there. I wanted to prepare a summary, but ended up with something like Christmas wish list. So we need the documentation. There is nothing, not a word from Apple about validating the connections to the privileged processes. We need code samples, and not the ones that I showed you, like the real code samples that we can use that are secure, just a little bit more secure than the ones that you saw. we need some information about the danger of the process identifier. Honestly, I didn't know all this don't trust the process identifier stuff before. And audit tokens that are used by Apple internally should be public and available to third-party developers. And there should be some kind of uninstallation API, because all these, we have no flow, no official flow to get rid of all these privileged helpers, and they are just left behind. If you're interested in the topic, I found 5 most interesting articles on that. Ian Beer had prepared a great description of the issue, of the problem with process identifiers. Also, the talk of Tyler Bohan is available on YouTube. Also, there is a very interesting thread on Apple Developers Forum when people start asking how the hell I do this. And there is a story on objective development by Christian from Little Snitch. They had almost the same stuff that we did and many other companies. And there is an article by Eric Berglund from, I think, 2016 about the problem that the privileged helpers are just forgotten there and they lie on users' machines and make them vulnerable. And also, I wanted to finish with some kind of call to action. If I could ask you to do one thing, it would be reporting to Apple that audit tokens should be made available to third-party developers. We all have this feedback assistant application on our Macs, so please help to raise the issue and to grab attention to the problem. The more reports we make, the more attention we get, and the quicker it is fixed. So, thank you very much.